Welcome. So in this video, we will look at grouping and aggregation using pandas. So this exercise uses the miles per gallon dataset from Seaborn, which is provided as a convenience for you as a CSV file. If you look at the content of this dataset, you can see it has information about cars, including importantly their fuel efficiency, the miles per gallon or MPG, and a couple of other characteristics, as well as the country of origin and the name of the particular car model. So in this set of questions, we will be doing some aggregation exercises using this data set. So let's take a look at the first question. The first question is asking us about the average mile per gallon. Now this particular question is asking us to report an aggregate statistics on all of the data. And this doesn't require any particular group by operation because it's simply aggregating over all observations. So what we can simply do is to pull the column under consideration, which is MPG, right? This will give us a series, and then call the function mean to get the result. Alternatively, you can call the function mean, which will calculate the mean for all numerical columns, and you will get a series having the mean for each column, and then pull MPG. Same results if we're only interested in the mean of the MPG. This one is slightly faster because it's not crunching these numbers for all of the columns. Okay. Now the second question is asking us to repeat this operation for each country of origin. So here we need a group by because we want to group repeat this aggregation for different groups. Okay, so remember the group by operation will split the data initially to different groups and then apply the function, the aggregate function, which is mean in this case, for each one of the groups. So let's do data group by, and then I'm going to put origin here. This will basically give us a group by object. But because I applied the group by on the data frame, I got a data frame group by. Now, if I do mean, I'm going to get the mean for each column per each group in that data frame. So I get not only the average mile per gallon per country of origin, but also the average number of cylinders and so on. So similar to what we have done here, we need to restrict the result to MPG. So we can restrict it after the fact. So I do mean, and I get my data frame, and then I pull MPG. Okay, or I can do it before. I can index the group by object, which will basically give me a series group by object, and then I call the function mean to do the aggregate statistics. Mean. Okay. All right, so in the second question, it's asking us to report cars having MPG more than the overall average. So the overall average of MPG is this number, and we want to select cars that have a mean higher than that average. So in this situation, we have the average, right? And then we are selecting based on values. So this basically can be done using a masking operation. Let's copy the question here. We can basically mask our data. That's the mask. And data MPG should be higher than this number, data MPG.mean. So we can overall average, give it a name, or copy paste the same formula. So I'm going to do data MPG higher than the overall average. That's our mask. And then we can use the mask to index the data, and we get the subset in which the MPG is higher than the overall average. Okay. So the question is asking us about the cars. So if you want to be more specific, we can pull the names of these cars. But that's the data frame, essentially containing only observations, only rows in which MPG is higher than the overall average. so higher than 23.5. Okay, next, the question number 4 is asking us about cars having MPG more than the average in the country of origin. So this is a more trickier question because in this question we're only interested in cars in Europe in which the MPG is higher than 27.8 and cars from Japan in which their MPG is higher than 30.45 and cars from USA in which their average is higher than 20.08. Okay, so let's take a look at this question. So what I'm going to do first, I'm going to do the group by operation and I'm going to do origin and then I'm going to select MPG. So this will give us the series group by object. And what I'm interested in doing here, I'm interested in only selecting these observations in which the observation is higher than the group mean. So remember, the group by object allows us to aggregate, to filter, and to transform data. So this particular operation is kind of a filtering operation because what we're interested in filtering, and we're only interested in these observations in which their value is higher than the group mean. So what I'm going to do, I'm going to express this in a function. And basically this is saying that the function, the filtering based on the current value of the observation being higher than the group, the mean of the group. All right, so I backtrack in here. Filtering will select observation based on a group characteristic. So for instance, we can say that the group mean should be greater than, for instance, 25. That is a filtering operation here. Now, what I want to do, I want to take the group mean and combine it with the individual value mean. So in this case, I want to transform, that's the third operation I can do. I want to transform my data so that each observation I get, I want to compare it with the group mean, and I want to have it higher than the group mean. So I'm basically taking each one of these values. For instance, let's take a look at, let's do data.head here. Insert toolbar. So I want to take a look at each one of these values, for instance, 18. And I want to compare this value with the group mean. And the group mean in this case is, for cars from the USA, is 20.08. So obviously this observation shouldn't be in the final result. Same for this one, and so on. So what this will give us basically a mask because this is an operation that returns true or false. So then what I can do with this mask, I can use it to select the observations from the data. So as you can see, we selected observations from USA in which the MPG of the car was more than 20.08. These observations, but for Europe it has to be higher than 27 point something. So we can sniff through the data to see the more details of what we're getting back. So we can do head 25. So you can see, for instance, in Japan, the threshold was much higher. The threshold for Japan was 30.45. So we only kept these observations that are higher than the national average. Okay. So the transform function will allow us to transform individual observation from the original data frame based on group characteristics, such as the mean in this case. All right, so let's take a look at the next question. Before we do this, if this seems to be a complicated operation, we can actually do it manually. So instead of doing this, what I'm going to do, I'm going to calculate the national average. Let's do it in a different way. National average is this one. Okay. And what I'm going to do, I'm going to merge my national average with the data frame. So I'm going to national average here, and left on will be country of origin, which is origin, and right on index it's basically right index is true. And of course, we've got a duplicate here. What's important for us to consider is that this is the national average here. So what I'm going to do, I'm going to put suffixes is equal to nothing and national. So we've got a new data frame in which we have the original values and the national average. Let's call this df2. And then what I'm going to do, I'm going to create a mask based on mpg greater than df2 mpg national. So that's my mask, and then I'm going to use it to index the data frame again. All right, so we get the same result here. It's a slightly different way to look at things. We had to calculate this the national average and combine it with the original data set and mask it. All right, so let's move on to the question number 5. The question number 5 is basically asking us to select a country of origin that has an average miles per gallon more than 30. So we've actually calculated this in national average, right? So we've calculated the average, and then the remaining is basically trivial. We basically want to create a mask on this series and re-index the series again. So if we do this, we can see it's only Japan, right? It's just such a short series that we can eyeball the results if we wish, but it's basically masking on the resulting series. Now let's consider the next question, question number 6. So this one is asking us to select cars in countries of origin which the average MPG is more than 30. So it's basically selecting countries from Japan in this case. So we can do this using grouping, or we can do it using merging basically. Let's call this high efficiencies countries. Because what we can do, we can take high efficiency countries and join it with the original data. So we can do pd.merge our data and then high efficiencies countries, and of course left on origin and right index is true. By default, it's going to be inner, but I'm going just to emphasize that this is an inner join because I want only observations in which the country of origin is in this. Now we have one value, so we could have done masking, but let's look at the general situation. Say we had a couple of countries in which the average MPG is more than 30, then a join is much more general operation. So if we do this, we only get a subset of this data frame in which the country of origin is Japan, right? So this is like doing it in 2 steps. Let's do it in 1 step using group by. So group by origin, okay. And then what I'm going to do, I'm going to filter now because I want to select observation based on a group characteristic. My characteristic is the following. Take the group, look at the MPG, calculate mean, and ensure it's more than 30. That's my characteristic, and I basically get the same results. Only cars from Japan are selected here. Okay, so let's take a look at question number 7. And this one is basically asking us for the minimum and the maximum MPG per country of origin. So let's do this. Let's do data.group by origin. Okay. Many often, if you're being asked for the common descriptive statistics, so to speak, we can do describe, and describe will crunch all of these descriptive statistics for us. Okay, so I'm interested in MPG here. So this will give me the count, mean, standard deviation, minimum, and quartiles, as well as the maximum values. And again, this is a data frame, so I want to select minimum and maximum. Since there are 2 columns, I'm going to use fancy indexing, and I get minimum and maximum here. So this is fine, except that it's crunching numbers that we don't need, which is not a big deal for such a small data. Let's just be more specific. I'm going to use the same group operation, but instead of doing describe, I'm going to be more specific. So I can be more specific and say I want the minimum, or I want the maximum, and then combine them. Or I can do aggregate and pass on the function that I want to aggregate. So I can do aggregate min, aggregate max. What's nice about aggregate is that you can pass in a list of functions, such as min, max, and it's going to give you the aggregate based on these functions. So it's a small detail in here, doesn't make a big difference because the data is small, but it allows you to be more specific, and it also allows you to pass on your own functions. Okay, so let's take a look at the next question, which is question number 8. And this question is probably not very meaningful, but it's an excuse to write our own functions when we do aggregations. So here, it's asking us for the concatenation of cars' names per country of origin. So you can see that name is a string, is an object, right? So if we do data.dtypes, it's basically name is an object as well as origin. So it's not a number, okay? So if we do something like this, of course it doesn't work because name is a string. You can't do minimum and maximum here. It actually worked. It basically gave us the minimum and maximum based on a dictionary order. So it looks like dictionary-wise, the minimum car is Audi with letter A in Europe, and the maximum is Volkswagen, so that's VW, right? Japan, USA. All right, so it worked, but this is not what we're asked for. We're asked for doing the concatenation. So to do the concatenation, we need to have a function that does the concatenation. Now the function sum here will fit the bill because it will basically stick these strings together. Well, the only problem with the function sum is that it doesn't add a space by default. As you can see here, it kind of just put these strings side by side. So what we need here, we need a more nuanced function that will basically put spaces in between these strings. So what I'm going to do here, I'm going to write this function. Let's call this function concat strings, for some string. Let's call it concat strings. Let's call it concat words because I want to emphasize that these are words. So I'm going to sequence of words. So what you need to think about, writing a function that will operate on a sequence of things, because this function will be called on the sequence of names in the series name, which is the last column here. So what I'm going to do, I'm going to put result is empty, and for each string or maybe it's a sentence rather than a word in sequence of word or sentences, results will be equal to result plus a space plus sentence. Of course, you can use reduce if you wish, probably makes it easier, right? Or if you are more advanced, you can do space dot join sequence of words. Right, as you can see here, it's up to you to write your own function. So concat words, for instance, let's do this concat words, hello there, bye-bye. Of course, this has to be a sequence, so let's make it a list. We'll add a space in between. All right, so what I'm going to do here, I'm going just to pass concat words to aggregate function, concat words. And this will use this custom function to concatenate these strings. And you can see here that we've got the space in between these two words. So this is an example of writing our own custom aggregation function and using it instead of using the built-in functions because they don't do what we're looking for. All right, so let's take a look at the last question, which is basically giving us more information. It's basically classifying cars based on their weight. So compact cars have a weight less than 3,000 pounds, mid-size car between 2,000 and 3,000, and large cars have a weight more than 3,000 pounds. How many cars are there in each category? So the first step to answer this question is basically to classify cars because this piece of information is not in the original data frame. Okay? How do we do it? Well, there are many cars here and there are many weights. So to simplify this, let's assume that we're only classifying one car. What I'm going to do, I'm going to write a function called classify, and this function will take the car weight as a parameter. Then I'm just going to do a simple if statement. If car weight is less than 2,000 here, return compact. Else if car weight is less than 3,000, so return midsize. Else return large. So my line of thinking is to solve it for the individual observation and then to apply it wholesale on the series using apply. So classify will just take one number and operate on it. So what I'm going to do, I'm going to apply this on the data. Of course, the column under consideration is weight. So data weight, those are all the weight. And then apply will take a function and apply it on all of the observations in the series, stuff like classify. Okay, so I can stick this to the data frame, so I can do data class if I wish, or I can put it as car class. I can save it back in the data frame, but that's not needed to do the grouping. One nicety of pandas grouping is that you can group by an external series as long as it has the same index of the original data frame. So I can do data.group by car class, and then I can pull count here because I want to count. All right, so for each one of these class, I have the count here. Now, obviously, it has the same count for each one of the column because we don't have a missing observation. If we had missing observations, the count will differ in between these two, between all of these columns. Now, I'm only interested in, on showing this value only once. So what I'm going to do, I'm just going to select one of the columns, maybe name, make sense here, and I get the count, okay? Again, the alternative, if this kind of seems a bit awkward for you, is to say, okay, data car class is equal to data weight. Now this will change the data frame. If I do this, and if I do head, I just added a new column in the data frame. When I do group by, I can put the name of the column. Will basically give us the same result. So it depends on whether you want to change your original data frame or not, but it's giving us the same result. And this shows that basically pandas can split by a built-in column in the data frame or by an external series. And that concludes this exercise and shows the different ways pandas allow us to group and aggregate data.